This is Algebra 2. We're working on practice test number 1. Alright, in number 1 we're asked to solve the equation. I guess 1, 2, and 3 we're asked to solve the equation. The first thing that I see is the right side has not been simplified all the way. So I'm going to simplify by distributing the negative 8. When I distribute the negative 8 into the 3m on the right side of the equal to sign, well, I guess the left side is not going to change. I'll rewrite the 128. On the right side, negative 8 times a positive 3 is a negative 24. Don't forget your m. And then a negative 8 times a negative 4, double negative is a positive. And 4 times 8 is 32. And then I have to copy down that minus 8m. Notice that we have like terms, a negative 8m and a negative 24m. I'm going to combine those like terms on the right, and I'm going to get a negative 32m. And then I still have my plus 32 that I'll copy down. Left side hasn't changed, it's still 128 as negative. Now it's time to move things around. Notice I have a variable on the right and no variables on the left. Let's say that the right side is reserved for variables, which means this constant of 32 is going to move to the left. The way that we do that is we subtract 32 on both sides, and the left side is now negative 160. The right side is a negative 32m. Then from here, we're going to divide by negative 32m, or negative 32 rather, divide by negative 32. What's left over, this m is by itself. So m is by itself, and what is 130, or 160 divided by negative 32? I think it's about 5. I want to say it's 5. Let me just do some math here. 5 times 2 is 10, so there's the 0. Carry the 1. I'm holding the 1 in my head. 5 times 3 is 15, plus that 1 is 16. There we go. So m is equal to 5. And why is it positive? Because of negative divided by negative, it is a positive. Alright, in number 2 we're asked to do the same thing, and it's going to be the same process. We want to simplify both sides. I have a negative 8 times an n, which is a negative 8n. A negative 8 times a negative 3 is a positive 24. The right side is a negative 8n plus 16. Now we have both sides with a variable and both sides with a constant, so it doesn't really matter which side I move to. I'm going to move to the left side. I'm going to say add 8n. You're gone. Oh, you're also gone. Interesting. I have 24 is equal to 16. Whenever I have a number equal to a number not itself, that means that's impossible. 24 is not 16. Whenever that happens, the answer is no solutions. And it's worthwhile mentioning right now, what happens if I have the same number equal to the same number? What if this said 24 is equal to 24? Then this would have been infinite solutions. Alright, number 3. Oh boy, we got a bunch of distribution. Let's go ahead and do this. Negative 2 times 1 is a negative 2. Negative 2 times a negative 3x is a positive 6x. Then we have a negative 8 being distributed times a negative 5, which will be negative, or positive 40. Negative and negative is a positive. And then negative 8 times a positive 5x is a negative 40x. The left side of that equation is still the same. It's still a 4. Alright, I have some like terms over here. I'm noticing that I have a negative 2 and a positive 40 for a total of 38. And I'm noticing that I have a plus 6x and a minus 40. That adds up to a negative 36. Or sorry, negative 34. So minus 34x. And again, the left side is still that 4. From here, it's time to decide what side is going to be for what. I notice I have variables on the right, no variables on the left. So let's say that the right side is reserved for variables. Let's move the constants to the other side. The way that we do that is we subtract 38 on both sides, sides. You're gone, leaving us with a negative 34x on the right. On the left side, we have a negative 34. And then our final step is to divide by that pesky negative 34, that coefficient in front of the x. When I divide by negative 34 both sides, you'll notice that this left side is a negative 34 over negative 34. Whenever you have the same thing over itself, it is just 1. So we get x by itself because these negative 34s cancel each other out. And x is equal to 1, final answer, and box it. Then we move into our group of word problems. So I'm going to read these really quickly. Number 4, it takes Willie 8 hours to harvest a field. Jolly can harvest the same field in 10 hours. Find how long it would take if they worked together. So essentially the general idea here is we need to add rates, but we don't know what those rates are. So we'll say that there is a shortcut for this one, which I'll get to in a second, but the general idea is we're going to be doing rate plus rate. That's not the shortcut though. Our shortcut looks something like this. You take the rate, which is Willie's rate is one field I'll say Willie. Willie's rate is 1 field per 10 hours. And then Anjali's field, I spelled that wrong, Anjali, his rate is 1 field per, that's the 10 hours. Anjali takes 10 hours, and then Willie takes 8 hours. Oh, that eraser was too big. So I can add these together because I can do rate plus rate. So I'm going to do this rate plus this rate to figure out the entire rate together. So I can say that we have 1 over 8 plus 1 over 10, and that will be equal to our answer. So that's essentially equal to x. But I don't know how to do this, so what I'm going to do is I'm going to, I guess I do know how to do this. I just need to get like denominators, and that's the hard part here. So what do we multiply? I could multiply by 8 over 8 and 10 over 10, but there's a faster way because both 8 and 10 can be divided by 2. So what I can do is I can multiply by 4 and 4 and 5 and 5, and watch what happens. This is going to turn into a 5 over 40 plus 4 over 40. That's going to be equal to x. And I guess the thing that I'm not doing a very good job of saying is x is not really our answer. X is the total rate that I can work. This should be equal to 1 hour per, or 1 field per how many hours. So really, if I'm doing a better job of explaining this, I should be saying this is equal to 1 over x, 1 over x. The rationale for that is this rate and this rate should be equal to this rate, and the rate is always 1 field per how many hours. This is asking the length or the number of hours, which is x. So the left side here, let me go ahead and grab everything. Oop, not like that though. Don't need that 8. Grab all this stuff, move it up here. I'm going to grab it with my shrink ray too, and shrink it down. Now that I have that, I'm going to combine our fractions. I'm going to say this is 9 over 40, and that's going to be equal to 1 over x, and then I can solve for x. I can take the reciprocal of the right side. If I take the reciprocal of the right side, I take the reciprocal of the left side, so it's going to be a flip-flip, and I get x over 1 instead of 1 over x, and this is going to be 40 over 9, and 40 over 9 is, what is that going to be? Well, I know that 36 over 9 is equal to 4. That's going to go to 4. And then the thing that I'm missing is another 4 over 9, which anything divided by 9 is just point that number repeating. So this is going to be 4.4 repeating hours. And I'm curious if I got the right answer, because I know that sometimes I make mistakes on word problems. So on number 4, I'm going to check my work by looking at the answer key. Oh, come on. Come on, iPad. There we go. Wow. A lot of stuff there. And I'm noticing that the answer key rounds to 2 decimal places, so I'm going to say 4.44 as opposed to my perfect answer that told me I was repeating every number. So it's going to be 4.44 hours. I will note that on the actual test, you will have the ability to use a calculator, and in this next problem, I'm going to be doing the shortcut method, so you can learn that one as well. Let's go ahead and read number 5. Working together, Totskin and Jack can mop warehouse in 5.14 hours. Had he done it alone, it would have taken Jack 9 hours. Find how long it would take Totskin to do it alone. So the general idea here is we always do this. If I were to do the left side, if I were to do problem number 4 all in one step, I would have had 1 over 8 plus 1 over 10, and then once I find the answer to this, I flip it, because we knew the answer to that came down here to 9 over 40, and then I flipped 9 over 40. The way that I say flip in math is I just put that all over 1. So this was the answer. If I had typed this exact expression into Desmos, this would have shown 4.44444 hours. So this is the shortcut. Now I'm going to label that the shortcut. And if you're being very clever, you know that Mr. Sindel allowed you to use calculators. You can just type this into a Desmos calculator and you're done. You can just memorize a formula. And I'm going to be using this formula right here to solve our answer, or solve for number 5. So number 5, I essentially have this. I have 1 all over these two rates 1 over a number and 1 over another number. And it's going to be equal to our answer of 5.14. And there's yet another trick that I can do on number 5. Because I know my answer, what I can do, here, I'll draw the first thing that I'm looking for. It's going to be 1 over 9 and 1 over, maybe I'll put T for Tuscan. This is correct, but what I can do, and there should be a plus sign down here, what I can do is I can switch this, and I can say this is 1 over 9 minus, or sorry, not 1 over 9, it's 1 over 5.14 minus 1 over 9, and that's going to be equal to Toscan's rate. So if you can remember that you switch out the minus sign and you're doing the overall rate minus one of the rates, then this will also work. And if you want to see a proof of how to get from here to here, you can always ask me after class, or maybe I can make a secondary video for it. What I'm going to do, because I already have a 5.14, I have to use a calculator. I'm forced to use a calculator. I want to show you how to type this into a decimal scientific calculator. So I'm going to go ahead and split view, open up my scientific calculator, and type this thing in. What do we got? So it's going to be 1 divided by, and then there's going to be a fraction down here, so it's going to be 1 divided by 5.14, and then after that fraction, I'm going to do minus 1 divided by 9, and I get my answer as 11.98. So I'm going to come over here and say this is equal to 11.98 hours. And again, it's a word problem. I do want to check my work to make sure I'm doing this correctly. Let's see, for number 5, was it 11.98? It is indeed 11.98 hours. And again, just know the formula, plug it in, and you got it. Alright, I think that was number 5. Yeah, okay, so we're on to number 6. A cruise ship left Diego Garcia and traveled towards Madagascar at an average speed of 27 miles per hour. A container ship left 3 hours later and traveled in the opposite direction with an average speed of 21 miles per hour. How long does a container ship need to travel before the ships are 513 miles apart? So I can tell just by the type of problem that I have, they're both starting in Diego Garcia. One is traveling towards Madagascar, and the other one is traveling in opposite direction. So essentially I have a picture that looks like this. Whenever you have a rate I guess it's a rate, a speed and the speed that are going in opposite directions, essentially you're just adding them, and you're kind of taking this arrow and saying, oh, I'm just going to add it on right here, and you're doing 2 arrows in one direction as opposed to 2 arrows in different directions. It's the same mathematically speaking. It's a way that we simplify our problem. So this is kind of like a distance plus distance, I can spell, plus distance is equal to distance total. So we can just add them. Again, the way that we find distance is equal to rate times time. So I'm going to have rate times time plus another rate times time, and it's going to be equal to the total distance. And we know the total distance is already 513. Let me go ahead and fill that in right now. It says the ships are 513 miles apart. That is a distance. So let's go ahead and label these. I'm going to do, I know one of them is a cruise ship, the other one is a container ship. So I'll put CR for one, and I'll just do R for ruse ship and O for untainer ship. Instead of cruise and container, I'm changing it to ruse and untainer. Alright, so this is R sub R, T sub R, and R sub O, T sub O, just for that second letter of the type of ship that we have. So the rate of the ruse ship is 27 miles per hour, so I'm going to say this is 27. And the rate of the untainer ship is 21 miles per hour. Do we have times for either one of these? When I look back at this problem, I see that there's not really any specific time. There's this line that says a container ship left 3 hours later, and that's it. So I essentially have 2 variables that I need to solve for. Whenever you have 2 variables that are unsolved for, you need 2 equations. So I'm going to go ahead and set up my second equation over here in a different color, maybe in black. Okay, how do we have a container ship left 3 hours later turning into an equation? So 3 hours later is the difference between their times. So we're going to have some amount of time minus another amount of time, and that's going to give us 3 hours of difference. So which one is traveling for more time? if the container ship left later, then that means that the cruise ship has already been traveling for a lot longer. So it's going to be cruise ship minus the container ship, or in this case, it's going to be cruise ship minus untainer ship, and that's going to give us 3. If I were to add the untainer ship to both sides, we get the cruise ship is equal to container ship plus 3. And I guess I'm not being really specific with my variables. Technically, what I should have is that these are time variables. So if I'm substituting my time variables back in, I can say that my r variable is really my r variable plus 3. So I'm going to say in here, this is going to be, I need parentheses to keep my order of operations correct. Everything in here is going to be time for my untainer ship plus 3, and this one is going to be the time for the untainer ship, just the normal one, is equal to 513. And then from there I can go ahead and distribute 27 into both of these terms, so I get this 27 time for the container ship plus, okay, let's do 3 times 27. 3 times 7 is 21, so let me write down the 1. And then I'm carrying the 2 on my fingers right now. 3 times 2 is 6, plus the 2 on my fingers is 8. So I have 81. And then this is going to be, there should be a plus sign still in between here, so this is going to be plus 21 times 0. Time for the container ship is equal to 513. Notice that we have like variables, the t zeros add together. This is going to become 48. Time for the container ship plus 81 is equal to 513. Subtract 81 on both sides, and that's going to leave us with 48 time for the container ship is equal to, oh boy, I'm going to go ahead and do another trick here. I'm going to add 19 to both of these because that's going to make the bottom one equal to 100. And if I add, it's supposed to be adding 19, that's going to make that a 32. So it's going to be 532 minus 100, which is 432. And then from there, I'm going to divide by 48, divided by 48. And I'm not sure what that is, but I think 32 divided by 8 is 4. 4 divided by 4 is 1, so I think it's 14 probably, I would guess. Let me check. If I do 10, no, that's too big, it can't be 14. Because I know that 10 times 48 is going to be 480. It's going to be a little bit less than that. It's probably going to be 9. I'm going to guess 9. So t sub 0 is going to be 9. Does that work? Let's see. 9 times 8 is 72, so I'm carrying the 7 on my fingers. There's the 2. Remember the 7, everyone. 9 times 4 is 36, plus the 7 is 43. Hey, okay, there's the answer. So the container ship, or now the container ship is traveling for 9 hours. Container ship is traveling for 9 hours. And this is kind of important. Make sure that you come back to the question, make sure you're answering what it's asking. You're asking about the container ship. If we were suddenly asked to do the cruise ship, we'd have to know that, oh, to get the cruise ship, we'll just add 3 to our answer because we were solving for the container ship. But we're looking for 9 hours. And again, this is a word problem. I want to go ahead and check my work. So 9 hours for number, what number are we on? 6. So 9 hours for number 6. And for number 6, we did indeed get 9 hours. We're doing it correctly. And number 7, a diesel train made a trip to the fueling station and back. Alright, whenever you're going a distance away and a distance back, it's going to be the same amount of distance there and the same amount of distance back. So I'm going to say that this is a distance equal to distance problem. And we already know that distance is rate times time. It's going to be equal to rate times time. So I'm going to call this one rate 1, time 1 for the trip there, and rate 2, time 2 for the trip back. So if we're trying to find the diesel train's average speed on the outbound trip, what we're really trying to find here is rate 1. So I'm going to make sure that I'm solving for rate 1 at the very end. If I accidentally solve for rate 2, I'll have to do a bit of conversion at the very end. So what do we have? The trip there took 9 hours. So the trip there is, so that's 9 hours. And the trip back took 12 hours. So we'll say time over here is 12 hours. And we don't know any of these two rates. It does say that the 15 50 miles per hour faster on the trip there than the return trip. So we need to set up a second equation to find our solution. Let's see. This in black. So I know that if I subtract the two, I'll get the difference of 15. So we'll say again, something minus something is equal to 15. And then which one is faster? Which one is bigger? It's 15 miles per hour faster on the trip there. So the trip there is the bigger speed. So we're going to say the trip there, or our rate 1 is a bigger speed minus rate 2. And then we can just add rate 2 to both sides. Add rate 2. And rate 1 is equal to 15 plus rate 2. So you can say over here, this rate 1 is also this rate 1. Therefore, this rate 1 is 15 plus rate 2. We'll say 15 plus rate 2. That's all in parentheses. Whenever you do substitution, remember your parentheses, because we're going to have to distribute this 9 over here. And that's all equal to a rate 2 over here, times 12. When I distribute the 9 into 15, that's close to 10 times 15, which is 150. Let's go down a little bit, so it's going to be 135, in pen though, 135 plus 9 rate 2 is equal to 12 rate 2. I notice that I have my variables on the right side, so let's go ahead and move another 9r2 over, minus 9r2. It's going to be 135 is equal to 3 rate 2, and then from there I'm going to divide both sides by 3, and we'll get rate 2 is equal to, what's that going to be? Well, 120 divided by 3 is 40. It's 40 something. And then the remaining 15, because I did 120, so 135 minus 120 is 15. 15 divided by 3 is 5. So I think the answer is 45. Oh, wait a second. We're trying to find R1. We just found R2. So to find R2, or rather to find R1, you take R2, which we have, and you just add 15 to it. So that means down here we can say R1 is equal to 15 plus the 45. Therefore, R1 is equal to 60. And that's in miles per hour, I believe, for our units. 60 miles per hour for rate 1. Let's go ahead and check. Word problems are always a little bit tricky. Number 7, 60. Number 7, we did get 60 miles per hour. Alright, and number 8, what's going on? Perry left the hardware store and drove toward his friend's house at an average speed of 20 kilometers per hour. Mike left 1 hour later and drove the same direction, but with the average speed of that 30 kilometers per hour. Find the number of hours Perry drove before Mike caught up. So they're both traveling the same distance, because once Mike catches up, they've traveled the same amount of distance. So again, this is going to be one of those distance is equal to distance problem, or rate times time is going to be equal to rate times time. And we'll say this is rate for Perry and Mike and Mike. So we have Perry traveling 20 kilometers per hour, so it's going to be Perry is 20. This can be equal to, what do we have here? Mike left at 30 kilometers per hour, so Mike left at 30 kilometers per hour. And we don't have these times here, but we do have this fact that Mike left 1 hour later. That's going to be used to build our second equation. That we can use a second color again. Let's use black. We say something's happening here with these two values. And 1 hour later, how do I make that? If I take their times, there's a 1 hour difference in their times. Difference is a subtraction, and that difference is 1. Who is traveling more time? Who's traveling the bigger number? You always do big minus small. So if Mike left 1 hour later, that means Perry's already been traveling. Perry's been traveling longer than Mike left 1 hour later, right? So we're going to say Perry, or the time for Perry, minus the time for Mike, is going to be 1. And I can add TM to both sides, add TM. And that's going to be, Perry's time is going to be 1 plus the time for Mike. And we're going to plug that back in. We can say it's going to be 1 plus the time for Mike. And this is going to be the time for Mike. Don't forget that we need to distribute again. So this 20 is being multiplied by 1. It's going to be 20. 20 times time for Mike is going to be 20 time for Mike. It's going to be equal to 30 time for Mike. And let's go ahead and subtract. Minus 20 time for Mike. Minus 20 time for Mike. You're gone, and we now have 20 is equal to 10 time for Mike. And if I just divide both sides by 10, we get time for Mike is equal to 2. So what were we trying to insert or find? Were we trying to find Mike's time? Find the number of hours Perry drove. So we weren't looking for time for Mike, we were looking for time for Perry. So how do I find that? I can use this equation that says, hey, we're looking for time for Perry. Just take the time for Mike that you found down here and you add 1 to it. So I'm going to come down here and say, really what we're doing is we're trying to do time for Perry, which is 1 plus that time for Mike. So time for Perry is actually equal to 3, and 3 is going to be number of hours, 3 hours. Let's go ahead and check our work on the back, make sure we got this right. Number 8 should be 3 hours. And number 8 is indeed 3 hours. Excellent. And then we move on to these percent type questions. As a general overview, remember that our formula is generally, we have an amount, I'll say an amount 1 times the percent 1 plus the amount 2 times the percent 2, oops. All of that divided by the total amount, which is the amount 1 plus the amount 2, and that will equal our final percent. Let's fill in our formula. So we got 6 cubic yards is an amount, so we'll say that's amount 1 times its percent, which is 12%. And again, I know that you can change 12% to a decimal. It's actually not necessary for these types of problems. You can ignore that. They do cancel out in the end. It's going to be adding the next amount, which is going to be 7 yards, and that's going to be multiplied by 38. It's all going to be divided by the 2 amounts added together. And if you do the order correctly, and you do amount first, then you can just pull these 2 first amounts down without having to reanalyze the problem. You can say this is just 6 plus 7, and that's equal to our answer. So, again, this is probably something you can just enter in the calculator, and that's exactly what I want to do to save time here. We have a calculator for the entire test, might as well use it. It's going to be a fraction. Top of the fraction is 6 times 12 plus 7, oop, that's not 7, plus 7 times 38. And that's all going to be divided by 6 plus 7. The answer is going to be 26. Kind of nice. So 26 is our final percent. So just make sure that you know what you're looking for. The sand content of the mixture is 8%, so our final answer is going to be 26%. Number 10 is kind of the same type of question, so let's go ahead and fill in what we have. When I say how many, that's really X, right? X pounds. So I have X pounds of bleached flour, which costs $6 per pound, so $6 per pound, plus 16 pounds of unbleached flour, and that costs $8 per pound. That's all over the 2 amounts added. So amount 1 is X, the amount 2 is 16, and that's going to be equal to the total cost, which in this case is 7. So to solve this one, we are going to first get rid of this denominator. I do that by multiplying both sides by this X plus 16 and X plus the 16. These are going to cancel each other out, and that's going to be 6x is equal to, let's see, what is 16 times 8? 6 times 8 is 48. I'm holding the 4 in my hand, so 6 times 8 is 48. I'll write down the 8 for us, holding the 4 in my hand, and then I'm going to do 8 times 1 is 8, plus the 4 is 12. And then on the right side, I notice I have a 7 that's going to be distributed into this x plus 16. I'm going to go ahead and do that now. 7 times x is, wait, why do I have an equal to sign here? I don't think that's right. this should be a plus sign, sorry about that. And then now this is going to be equal to 7 times x is going to be a 7x. How do I do 7 times 16 here? Well, I have 7 times 6, which is 42. I'll write down the 2. And I'm holding 4 in my fingers. And I do 7 times 1, which is 7, plus the 4 in my fingers is 11. So this is going to be 11, 2, or 112. This is going to be added, and then we just need to solve. So I'm going to subtract 6x, subtract 6x. It's going to give us an x over here. And that means my constants need to be moved to the left side. Let's go ahead and do that in a different color. Let's subtract 112, subtract 112. That's going to be 16 is equal to x. And what does this mean? We're looking for how many pounds. So this is going to be amount of pounds. The answer here is 16 pounds. In number 11, all right, it's kind of the same thing. It's a mixture problem. So we're going to say we're making 9 gallons of fruit juice. That'll be useful at the very end, and it's 30% juice. That's the final answer that we're looking for. Again, the equation that we had from before was it was final percent, right? So I'm seeing a final percent number already from our problem. The final percent is 30%. So I'm going to say over here it's going to be some sort of fraction, and that's going to be equal to 30%. So we have brand A, which is 34%, times some quantity that we don't know, so it's a little bit off. You can see it's right here. So brand A times 34 plus brand B, which we don't know the amount, and that's going to be times its percent, 16%, and that's all over the two amounts added together, which again we don't know. So notice that we have an equation, one equation with two variables, which means we need two equations, and that's where this other number comes in. If I add together these two numbers, it makes 9 gallons of fruit juice. So I can say over here, I need to make some room, so let's move these a little bit closer together and save some room. We can say over here, if I add A and B together, I get 9 gallons of fruit juice, which means I immediately rewrite you and say you're 9. So we're going to make a new fraction and say 9 is on the bottom, 30 is on the right. But now we need to do substitution. Either this A or this B need to go. So I'm just going to arbitrarily say, hey, let's just subtract B. If I subtract B, I'm going to get A is equal to 9 minus B. So if A is 9 minus B, this A is 9 minus B, and I can say 9 minus B. Always put it in parentheses, so you remember to distribute, times 34, and then I have to rewrite the rest of this, plus B times 16. Let's go ahead and distribute. So it's going to be 9 times 34. Let's do this in our heads with fingers. 9 times 4 is 36. So there goes the 6. I'm holding the 3 in my fingers. 9 times 3 is 27, plus the 3 on the fingers is 30. So it's going to be 36 or 306 minus 34b plus 16b. And that's all being divided by 9, but I don't want to divide by 9 here. So the opposite of divide by 9 is to multiply by 9. We'll say the left side is multiplied by 9 if the right side is multiplied by 9. Those will cross cancel with the 9s. Right side will be 30 times 9. Again, hide the 0. 3 times 9 is 27. Then add back on the 0. 27 add back on the 0 is 270. I'm noticing that we have some like terms. I have some b's, a negative 34b and a 16b. That adds together to be, what is that going to be? Pun unintended here. That's going to be 18, I think. Negative 18b. And I still have this 306 out here. That's going to be equal to 270. From here, I'm going to subtract 306. Subtract 306. And then I'm left with negative 18b is equal to, what is that going to be? That's going to be, I think that's negative 36. Negative 36. And then finally, divided by negative 18, divided by negative 18, and b in this case is equal to 2, a positive 2, because of negative divided by negative is a positive. Were we trying to solve for b? What were we trying to solve for? how much of each do you need? Well, B is 2, so we need A and B. How do I get A? So A, I have B. No, well, to find A, just take, I was about to do that on laser pointer. Take B and then do 9 minus that amount. So 9 minus 2 is going to be 7. So I can say A is going to be equal to 7. I want to check that one, just to be sure. I'm thinking that B should be 2 and A should be 7. B should be 2 and A should be 7. Yeah, everything looks good there. Let me erase all of the circles so I can see what's actually going on. Cool, and that's going to end part 1 of the video. I think in part 2 I'm going to do number 12 through, what's the last number going to be? Number 12 through 23.